So, well, that's me. The reason because I am so passionate and interested in this topic for designers is because I feel that we shouldn't limit ourselves as a designers to be consumers of the technology, just to generate images for our creative work or test or um, data visualization or whatever it is. So just being consumers is not going to be enough for us to go through the noise and be in the front and center of the innovation. So I believe that as designers, we need to embrace artificial intelligence and understand the general concepts and technical parts of AI. And that is what this talk about. And I hope that at the end of this talk, you can leave with like a clear series of steps that you can apply in your job position to determine which parts of the product that you are helping to design can be benefit of AI. I we know we are problem solvers, and that is what we are meant to be. And my hope is that yes, we be part of this revolution. And it's interesting because the term artificial intelligence right now sounds like a buzzword, but it was coined more than 70 years ago, if you think about it. But the thing now is that, well, hardware is getting cheaper to run. We have more data that is being collected at the edge through devices, call it cell phones, computers, network devices, etc. So we are dealing with tons of data that before we didn't have. And well, ChatGPT appeared and allows that any person that has a computer and internet connection could access the benefits of artificial intelligence. So that is the reason because I thought, okay, it's a good moment to introduce part of the technical side of AI for us designers, and from there start talking with more authority when we have to have these conversations with product managers, developers, data science, machine learning engineers, and not feel that we are just there to make things look pretty and that's it, because they already thought about the solution and they already figured out the machine learning model and the features and everything. So that is what is this talk about. So I am assuming that we are very familiar what artificial intelligence means, but I am bringing this graph here because I want you to bring your attention and focus on in three areas of machine learning and deep learning: computer vision, natural language processing, and recommendation systems. And this is because most of the solutions or ideas that you are going to have during your time as a designer will probably fall in one of these three fields. And I'm almost positive sure that a model, a pre-trained model already exists in one of those fields. So you don't have to start from scratch. So computer vision, natural language processing, and recommendation system. There are way more, but these three are the ones that you will see more often in diverse industries. So let's go through some examples so you will start identify those in your day-to-day, and you'll say, oh, you know what? I know this application that use this or that, and you will start recognizing that AI is becoming very ubiquitous and everywhere. So computer vision, I'm bringing the example of biometric authentication. Biometric authentication is not just face recognition, it's as well the fingerprint recognition, the retina recognition. Suppose that you are designing an application for financial application, for finance or for cryptocurrency. And it's important to keep the integrity of the data through the authentication of your user, instead of asking for disentangling an image or asking for filling a lot of fields, you can utilize a model that exists where you can validate the identity of your user through facial recognition. And this is just a minor example. You just start digging, you will start seeing more and more cases. Let's start, for example, in agriculture, they are starting to use them to count heads of cattle and things like that. In the field of here, natural language processing, the most common is chatbots. And at some point, chatbots become the annoying thing that start appearing in almost every website, and you wanted to get rid of them because they were not giving too much value. But they are becoming more sophisticated. And what you are seeing now is that they are being integrated in assistants and copilots that are using less demanding or structure prompt to help you to accomplish certain tasks. The latest is the Copilot from Microsoft. It's doing a good job. So I encourage you to just go to the website and see the demos and learn from that and be curious on how they are communicating to the user, the results, and how the user interact with the interface to refine those results. And in recommendation systems, you are very familiar with this. You have seen those in your Netflix subscription, YouTube, e-commerce. You will see it in almost everything that is trying to sell you a product or engage you with a service. Here I am bringing an example from enterprise, and it takes time to get to the level of sophistication that the business to consumer applications have, because enterprise has more restrictions. So in this case, what you're seeing is an interface, a wizard for a user to enter certain attributes to get a storage, data storage, to upload a workload. A workload could be a website, could be a database, could be a system for sending and receiving email. Whatever, here the user comes, give a series of attributes. As you see, there are good number of attributes because at this point it's still needed. And then internally, the software calculates in the inventory of servers that this company has, which is the best server that can provide the best performance for that type of attributes that the user is entering in here. And in the second screen, what we see is graphical representation of that server, and it tells you, we recommend you this, it's a high headroom availability, so go with this. But if you don't want to go with that and you don't like it, just please go against our recommendation and do whatever you feel doing it. So those are examples from those three pillars of fields in machine learning and deep learning. And again, I brought this to you because every time that you interact with an application, I want you to think, to be conscious, okay, where this belong to, how I can take these ideas and put it to work in my own process. Well, surprise, AI cannot do everything because, well, algorithms are limited by their data set. And also, algorithms are probabilistic functions. It means that it's always going to have a margin of error. It's not going to be 100% accurate. It takes all this data, do calculations, and based in these probabilities, it tries to give you the best output. So keep in mind that when you are thinking about introducing artificial intelligence in your design process. Following this, I want to talk about how artificial intelligence learns. And I think it's important that you have a clear understanding how these algorithms learn, so you could start thinking about your data set or the data that your company owns or can borrow to develop solutions. So there are three main ways that AI learns. We have supervised learning, unsupervised learning, and reinforcement learning. Supervised learning needs a database that has clear structure, features, and labels. Let me give you an example. Let's pretend that those purple, red, and orange and blue dots are data points to calculate prices of a house. So in the first feature, you have the number of rooms. In the second feature, you have the size of the house. And in the third feature, you have the years of construction of the house. And the label, the Y, is after the combination of those three factors, you get a price. So you had a large data set of houses in a neighborhood, and you decide to create to feed a model with that data set, and using a neural network, you are going to create an interface so your user enter those three features and give you an approximated value of the house. Remember, there always will be a margin of error, so the results are not precise, and that is an important factor to keep in mind when you are designing solutions with AI. Do you need to be explicit about that in your interface? Your industry requires that? Or it's okay to have that margin of error and not tell to the user? That is supervised learning. And what you see under the very well-aligned dots is a simple neural network with one hidden layer. Those lines that you see, they're nothing else but linear regression. So you go to 10th grade math and remember the linear regressions in statistics. This is what is happening. Every one of those columns, the purple, the red, and the orange, are creating linear regressions that fit other linear regressions to finally give you a result. And this is a simple model. There are models that can have 10, 20 hidden layers. So imagine the cost in energy and power server that is required to do those calculations and give you the results that are expected. Okay, that's supervised learning. Let's talk about unsupervised learning. As you see here, you have a set of data that has no structure. Let's think about you are collecting reviews from a product that you are fetching from the internet, and you have 5,000 reviews with different verbiage, with different attributes, positive things, not so positive things, and as different as people could be. You put this into the unsupervised learning model, and what this model is going to do is going to cluster the data and find common things that make sense and classify that data for you. After you do that, funny thing is that you could utilize that now structured data to do a supervised learning model. So as you see, things start complementing each other. And the last one, and one that I find fascinating, is the reinforcement learning. And here you have an agent. An agent can be an autonomous vehicle, a robot that moves things from point B to point C, or a chat, a bot chat, such as ChatGPT. The engineers start training this agent with basic tasks, and every time the agent gets accomplishes the task, it receives a reward. So how something that is inanimated could receive a reward? We are talking about a mathematical equation that provides points, like a video game. Imagine that, okay, the more points the better you do, the more points you receive. There are cases where engineers are so eager to make this work that make the reward really huge. Let's say that does 500 points if the agent, the robot moves the box from A to B or whatever. And that can cause bias in the agent. Let me give you a more specific example. Some time ago, a group of engineers were training some chatbots to work as a sales agents. Then the chatbot, after many conversations back and forth, obviously chatting with people that should be buying things from the chatbot start noticing that when they start enlarging or exaggerating the features of the thing that they were trying to sell, they were actually getting the sale. So they very quickly start learning that they could lie and then get out with the results that, I mean, at the end, they had to sell, isn't it? That wasn't the reward. You didn't tell me that if I lie, so I will lose points. You just told me, go sell. And that is the black box. We understand when we start feeding these things, but then when they start getting sophisticated and more neural network, more layers in the neural network are added, we lost track and we get what is called the black box. So there you have supervised learning and reinforcement learning. So keep those ideas in mind because it will help you later when you start framing problems to identify those uses, those cases that can benefit from AI. Yep, let's move to the problem framing. So as everything starts with knowing your user. Here, I'm not going to deep because I know there are very seasoned research and they know better this type of methodologies. As you see, we still, humans are in the loop. So talk to people, observe behavior, look at existing data to identify a problem. You identify that problem, nothing has changed here in your process, in your ideation process. But then you start thinking in that user journey, okay, and start this, sorry about that. And you start dissectioning that solution in specific tasks. You want to identify tasks that are boring, monotonous, and repetitive. Those are the best candidates to introduce machine learning or generative solutions. Once you identify those, then think about if you really need machine learning or any AI generative model to get to that point. To determine that, ask questions such as, first, will your product predict or generate an outcome? If the product will predict, do we have reliable data set to work with? If you think about predictions, sometimes a simple linear regression will do it. And then you don't need to introduce such a complex models. When you go to generate outcomes, so then things start getting more complex. And think about if you are going to automate that task or you are going to augment your users' ability to do the tasks themselves. And this is very important because not every user will want to give complete control to an algorithm to accomplish a task. Many of them, because different regulations, experience, situations need to be part of that process and be the monitors of that from beginning to end in the completion of that task. So we cannot just say, oh, yes, we can automate it, but does the user really needs or wants that? So keep in mind those 3 questions for the step 2. And finally, establish success metrics. So here I want to clarify that we are not talking about the metrics that measure the precision of the model. We're going to talk about those later. Here we're talking about business metrics. It's just going to help to achieve more engagement, click rates, channel behavior, because yes, we advocate for our users. There is no doubt about that. This is one of our main ethical pillars. But also we work for companies and we need to align those with the strategy of the business. Other thing that I want to add, especially in point number 2, when you are getting excited and you say, okay, I found my, what happened here? I guess that I lost my share screen. I'm going to share. Well, I was saying that when you get excited, you say, yes, I found those repetitive, boring tasks. Definitely we can automate it. We had the data set. Yes, okay, good. So it's really worth it once there is a real benefit for the user. Second, how much does it cost to create that, implement that model? Human cost, machine cost, environmental cost, and how much does it cost to maintain that model over time? Yeah, it's not just at the moment, but over time. Remember that if we introduce machine learning, the model will keep receiving feedback and learning and growing and getting better. So keep in mind those things. Let's talk about once you got that figured out, you have green light, your product manager is super excited and say, yes, you got this. So our job doesn't stop here, and we need to start thinking a little bit as data science. That means that I encourage you to get involved to learn about how is the structure of the data that the company has. Use common sense, which features that the data set has can actually serve a purpose to get the result that you are trying to achieve. Here, I'm showing you an example for a predictive model. If we were talking about generative models, probably we were talking about clusters and different methodologies. But the predictive is, I feel that is the most digestible at this point. So here what you are seeing is a small sample of data from a hospital that is trying to predict if a patient, after staying in the hospital, after a surgery or treatment, and when this patient leaves, in the next 30 days, how is the probability that that patient come back because he's sick again? So the question here is, what is better? What is better here? If I am building my model, should I introduce the 4 variables, or should I stay with the first and the second variable? So, well, you use common sense and you start from there. But there are methodologies to help you to determine that as well. So let me show you this in a graphic. Don't think about the math. Just keep the concept in general. So we are plotting here a regression. This is a different example. This is calculating how much fare per passenger can cost, depending the distance. So in the first case, what they are doing is that, okay, just throw one variable to the model. Let's say distance. So easy. The longer the distance, the more expensive. Done. As you see, the line red and the blue points, the distance between the blue points and the red line, that is the margin of error. And remember at the beginning that I told you that there will always be margin of error that is almost impossible to eliminate and still have a functional model. So here's when you need to evaluate those things. So you can say, okay, that's sufficient. One variable, why not? Sometimes we will be very accurate, but the further is the fly, we start losing track and not so accurate. So what about if we introduce a second variable and we take all the historical prices that connect with those distances? As you see, the line curves a little bit. then it starts getting closer to those points. And if you add another variable, so you will get that line with a little more curve, and the error start getting smaller and smaller. What happens if we throw 6 variables? Let's imagine things here. Distance, historical price, number of bags, food that the person eats, selecting the chair, selecting the time of boarding, and then you add all those variables to your model and say, okay, yeah, wow, definitely there's no error practically. Looks great, isn't it? Well, we should go with number 3. Well, not so fast. If you're going to model number 3, it means that your interface will require that your user enter every one of those variables to get accurate results. Either start skipping variables, the model, it's not going to be accurate. So think about that. If you remember in the sample recommendation systems that I was showing you, that wizard had like 6 variables that the user must to enter for the software to give you an exact recommendation of that, the best server that can help you with your workload. Why is that? Because we still need to keep working in making the models more sophisticated to a point that we need less and less variables to predict those systems. So there you start seeing a balance and a trade-off in number of variables and the accuracy and the results that you are going to get from your model. It all depends on your industry, all depends on the data that you can collect. It all depends on how sensitive is the information that you need to provide at the end of the result. Okay. I hope so that it's not getting too heavy this and I'm not boring you and still have your attention. I feel that I need to breathe a little bit. Okay, let's finally talk about metrics. And these are the metrics for to evaluate the model. We have recall and precision and recall. There are way more, but as a designers, I think that these are the most important to keep in mind. So at this point, we are already into the weeds. We already selected variables. We already test our model with a subset from the data. We are in conversations with our data science and our developers, and then we are like, okay, what are the results that we are getting? And those results are, I mean, they work for our case. So you think about precision and recall. So basically here, what we are trying to do is to manage how many false positives you want to tolerate in the prediction. Keep in mind that a false positive is a mistake where something that is identified as a true or positive is actually a false or negative. Let me give you an example. Let's pretend that you are designing a TV show recommendation application. And after you have all that historical data of your users, you start getting these recommendations for different types of users. So you evaluate. I go with high precision or high recall. You cannot have both. So if I go with high precision, all the blue, green thumb ups are TV shows that my users for sure are going to love. But because it's high precision, I'm going to miss some of those very accurate results that still my user could see, she's going to miss it. But guess what? Good news. Nothing that is not in her life is going to be in that mix. So does it benefit the strategy of my business? Let's go. Let's see recall. Let's say that I'm going with a lower precision and I am in the higher recall. So what is going to happen here is I'm going to include all the true result, the true shows that my persona is going, my user is going to enjoy. And here and there, there's going to be one or another child that probably she's never seen or not interested or not like it, but who knows, maybe she ended like it. And we create a new stream of engagement there. So think about those cases. This is a very trivial example, but let me show you how not understanding well this precision of recall measurements can lead into bias. Now let's pretend that you are creating a job application screening system that relies on historical data from large tech companies here in Silicon Valley. Suppose that the data shows that most employees hired for a specific job in tech has been occupied mostly by white and male people. And the screening system uses a high precision measurement. So the left side where you see three thumbs up. Well, you as a designer say, you know what, this seems a good idea because it will expedite the process of hiring. It will make more efficient recruitment. And although I'm going to lose some potential candidates, I'm still in the range of what this historical data has been showing. Well, guess what? If you go with this type of model that uses this high precision, so you are going to skip other populations, such as African American, women, indigenous population. So then you start introducing bias in your system. Okay, so let's do a recap. Here, these are the main points that I want you to take home. First, familiarize yourself with the three primary fields of machine learning. If you are entering into the field, if you are more advanced, so let's keep it. Keep in mind that AI is based on probabilities and depends on the quality of data received. Understand how AI learns so you know what you can do with your database. Identify very specific tasks that are repetitive and tedious. Determine whether you are trying to automate a task or enhance your user abilities, and learn from your user if they really want to give out complete control or is beneficial for the user. Decide if your solution requires artificial intelligence and whether the model needs to predict or generate, because that will change what type of model you are going to use. Evaluate whether the solution can be implemented quickly and generate immediate benefits. You are talking with your product managers and the developers, and they say, your idea is great, it's fantastic, but it will take 6 months to a year to implement it because we don't have the data, we don't have the technology. Probably you need to move to another task and think different solutions and different things because probably it's going to be too late to introduce that. Evaluate whether align success metrics with the company's strategy. Be involved in selecting variables and metrics that govern the ML model because that will help you to be worthy of the ethical concerns that machine learning brings into our lives. And identify those gaps in data security and any ethical compromises. So that's it. That is the technical part. I hope that it gives you some kind of taste of what we face when we start having these conversations in companies and managed enterprise or products in general. I want to move to something lighter after boring you with all these technical facts. It's about user interfaces and AI. This is a very personal opinion. I do believe that tools and technologies evolve, but the design principles are timeless. However, because we are now talking about interfaces that are receiving information from the user and are improving every day, so things are changing a little bit. Specifically how the machine receives the input and how it generates the output. So I believe that we are going to still having a lot of graphics around. They are not going to go away, but they need to be more precise, easy to read. I mean, it's like nothing has changed. The principles are the same. And the machines, as I showed you in the examples before, you will see that right now, for example, when you use ChatGPT, you need to have a well-structured prompt to get a good result. Otherwise, you're going to get just an average result that probably you cannot use it. Oh, it's so obvious that was generated from a machine learning algorithm that you cannot use it, or you had to go and do a lot of edits. But little by little, we are seeing that these models are becoming more sophisticated, and they are needing less input from the user, less fields that need to be selected, less structure in the input that they put, more natural language, more the way how we speak, how we communicate with other humans, but still the results that we are seeing, it needs some graphical representation that can be easy to interpret. And I want to finish with skill sets for us designers in the AI world. I feel that it's important that we have like a clear understanding what things we need to start adding to our tool bag that we weren't aware of those before. I divide this in 3 pillars. It comes from research that I have done, articles that I have been reading. I consume a lot of information around this. So I try to summarize this and make it as easy to remember. So in the technical side, definitely we can explain the basics of how machine learning works, understanding data, how it's collected, how it's cleaned, curated. We were talking about, okay, let's use a common sense, but then let's go and understand the graphical modeling of that data and see how the results are, and if those results actually fit what we need. Learn the AI techniques. You don't have to go into understanding completely all those mathematical equations, but definitely you can identify natural language processors, computer vision, recommendation system, and so on. Learn how core algorithms work. Linear and logistic regressions are the most common in predictions, neural networks. Clustering is for unsupervised learning. So just get familiar with those so you know what you're talking. And research a little bit more about how to select a model. What I show you today, it's only a little bit of how you can select a model for a predictive application when you want to predict a result. So you want to do a clustering for unsupervised learning, so the model will be different, and yeah, the functions are going to be different. On the ethics side, this is for everybody. Be a guardian to avoid bias, ensuring that the privacy of users and their data are respected. Think about the impact in the environment when you are introducing artificial intelligence in your systems. And on the strategy side, well, be confident in talking about which barriers you can encounter for your users to adopt AI. Get familiar with real-life use cases in diverse industries so you can talk about opportunities, functionalities. Know your company's AI strategy and differentiation if they have one. If they don't have one, be the pioneer, be the one confident enough to introduce these concepts, these ideas, to say, I found that this task can be benefited if we introduce a machine learning, and I believe it should be a predictive one. And I think that we had the data to do it and have a small test and see it, how our users react with a small group of users. And understand success metrics for any initiative that involves artificial intelligence, success metrics that align with the business, and then on the technical side is the success metrics for the model. And that's it. I hope that you guys found this enjoyable to some extent. I want to finish with an invitation. I am creating this Facebook group for designers where we can post about different examples from different industries, learn things that are happening, grow our knowledge from a design perspective that is way different than how engineers are processing this information. And of course, if there's my LinkedIn profile and you want to follow me, I am trying to post information more often about this topic. And thank you so much. Is there any questions? I hope I can answer them.
Before we get to Q&A, everyone take yourself off mute and let's give a quick round of applause.
Woo!
That was amazing.
I'm glad that you like it, guys.
Sorry, I got a little Tasmanian devil over here.
I got you. I have one too. Who just turned 1 year.
Okay, so if you have a question, you can use the raise hand feature on Zoom. If you go down to the cursor or the icon for reactions, there's a button for raised hand. So, got any questions?
I guess that I should stop sharing my screen at this point so I can see who is.
Sure.
So Cassie Anderson.
Hello, thank you for the presentation. I was wondering if there are any AI tools that you might recommend for designers to use in our design process to speed up or to help move iterations faster.
Yes, I don't use them personally because right now I am in a company that we had a very rigid design system. So we take components and do things. But I went to a conference and there was one that I believe it's called, let me find it and I will put it somewhere, but it's from Australia actually. And I was very impressed what they're doing. It's exactly what you are mentioning. You just enter a series of inputs and then I want to create an application to give get an adoption street cuts, and then these are the colors that I want to use, and it gives you all the screens and all the possible paths that your user will follow. And I was like, oh wow, like that's something that we can use. So yeah, let me research and I will try to put it in the chat.
Thank you.
Any other questions? I had a question. I'm assuming like you're working with a data scientist when it comes to determining the learning model. Did you work with a data scientist on that?
Absolutely, and machine learning engineers.
Okay, because I asked that because I've been on a lot of product teams where they want to like use AI in the products, but they don't have a data scientist on the team. I'm wondering like how would you navigate that?
Okay, so the data science help you to get insights from the data. So yeah, so a little bit of massaging the data and tell you, okay, this is the results that you're getting from your data using this and these variables. And then when you want to go and create those models, so you use machine learning engineers. And some data science are starting to step in the machine learning world. So you kind of need both.
Got it. Okay, thank you.
I mean, the line is very, very thin, and both had different job descriptions. But if it feels that yes, you need both.
Sophia.
Hello. So thank you so much for the talk. Really, really interesting. So my question is, I'm going to see if I can articulate this. So in the example that you gave with, I think it was like patient data, I think it was for the supervised learning example, and you showed a table.
Yes.
And so like a lot of the data, like it was age,
Yes, we can go back to that. Let
A
me go
lot of
back
it
to
was
this.
patient data, like age, but then I also saw length of stay, which would probably be housed in a separate database. That would probably be like,
Okay, let me go back really quick here. So we are talking about the, sorry, I was extracting these examples from different cases.
perfect,
So,
perfect.
okay,
Okay.
so tell me
like,
about it.
age, gender, number of medical conditions
Mhm.
would be about the person. Like that would be on the
Yes.
object.
So every line that you see, every row is a
Mhm.
person. So this is
Right.
historical data, and
Mhm.
you have okay. Remember that for supervised learning, we say we need a label, a wide result. So this is people that for I don't know, let's say for the last 3 months, they collected this data from these patients. And if you see, some came back, some never were seen for the next 30 days. So this is historical data. Now, what they're trying to do here is that with that data, which I believe is bigger than that, trust me, there are more features. So let's see if a patient that stays for 10 days at the hospital and is 33 years old and is a female and has 2 medical conditions will return to the hospital in the next 30 days. So we can be prepared.
Right. So my question is actually, so these fields like age, gender, number of medical conditions, that is all about the person, but actually length of stay and readmission would be about the stay or like a visit object. So it'd be like an admission, right? So because there's a many-to-many relationship. So a person in the database could have multiple stays.
Mm-hmm.
That's probably going to be housed in 2 different databases, or that's going to be pulled, like the length of the stay might be in a different database. So basically my question is, when you have these relational databases, what kind of challenges does that present when you need to train a system on a relational database? How do you have to clean up that database? Do you have to put in like a lot of foreign keys? Like when you have a foreign key, is it really good at like going and referencing the foreign key?
I will love to give you those answers, but unfortunately, I don't go that far from that. That's like the data science that help you to put that. But yes, you are right. Some features can belong to a data set, and others that include the same patient can be in another data set, and you need both or 3 or 4 to make sense of the whole patient in this case to then use it to fit in the model. So I imagine that here what we are seeing is a condensation of those databases to give you very precise lines for every patient. And I assume that this is what they believe that as the 4 features that get the best result in this example.
Yeah, yeah. I mean, I'm just even having trouble
So
with that. Just
I'm sorry, I cannot answer that question, unfortunately.
cool. Thanks.
Any other questions? I have another question about like you mentioned the ethics of AI. In my experience with some of the product teams I've been on, they've been like very aggressive about like almost, well, some of the product teams I've been on, they pursue AI because it's a buzzword, right? They don't really think about whether or not it's the right fit for the users. But they're like, we need to jump on this AI thing, and we need to launch fast. We need to launch like now. And you know, all the stuff that you were talking about, figuring out the learning model, figuring out how to even train that data, what are we even trying to accomplish with AI, etc. I struggle sometimes with figuring out how to get product or like the business stakeholders to slow down without coming off like a blocker or coming off obstinate, because I am concerned about like the ethical concerns, or you know, or like I don't want to just launch like a crappy feature just because we want to cram in AI so quickly. What are your thoughts on that?
Yes, so there are like 2 concerns that you have here. So are the technical side, like do we have the resources to put in the market something that actually provide value to our user. So do we have the data set? Is reliable? Do we have the people? And do we have the research that help us to understand what our users will benefit from without compromise their security, their all the things that it says the ethical part. I think that if you manage and appropriate those terms, and you can with those you can to the table with those questions. So from the technical perspective, so you start finding that there are a lot of barriers to get to that solution. If you always check, yes, we have the database, yes, we know, yes, we understand, yes, no, we have the security measurements, so there's not going to be leaks in the data and blah, blah, blah. So then the second thing that you need to ask is like, do we really understand our user needs? Do we really think that our user wants that we completely take the user out of the picture and automate this thing for them? So yeah, I will. And the other thing is that what you say, how confident is the result? If it's a crappy result and it's only 85% or 70%, and we're talking about a medical application, will you go to the market with that thing? I think you're going to end in jail if you do something like that, isn't it? So no, definitely it's a big no. So to summarize, my point of view is start with the technical. So in the technical, you start putting all those barriers, and then move to the ethical and security concerns that you have. And then if any of those things, put a filter of a stop there to make think twice. So then use your US research tools and talk about how this will impact your user, and it really benefits the user and brings a return on investment on the company.
Havana, I had that situation just a few months ago, and we actually tested. We went out and found similar websites that had chatbots, and we found out that people avoided them. So we just went back to the client with saying, 9 out of 9 people didn't want to use it.
Yeah, yes, especially with the product management, it's like that. It's like, we need to be there, we need to get it. And let's like, but wait, let's go back to our basics. Let's go to our users. And still there is a little bit of low confidence in the side of the user for many of these tools to get adoption.
Would say, from what I'm seeing, it's not just low confidence, it's like absolute mistrust. I'm seeing kind of two dynamics. One is in organizations that are VC funded or pursuing VC funds are very like pro hype, pro push something out the door immediately. And users don't react well to, here we threw AI on something. And it's not just like, I'm not using it. It's, can I still trust this company at all? Which is a pretty big risk.
I agree. Yeah, go back to your basics.
Sorry, go ahead, Lauren.
I was just saying to kind of follow up on what you're saying. We've used it for in 2 different ways, like pattern recognition to simplify workflows for users. I work in construction software, so to help read different architectural blueprints and try to use pattern recognition to be able to do estimating. And we've learned that workflow is so important to the user. Making that simple is actually not helping them. So we're instead taking the models and using them to help searching within the website for jobs. And that was a better application to actually help reduce their time in their workflows, to actually be more delightful and helpful to the user, instead of trying to kind of simplify complicated workflows, because those are important to them, into their knowledge, into their learning to do their work.
Yeah, that's a great example. I mean, couldn't be more precise to give a clear understanding of that. Yes, like no giving up or the learning that you are going through, those user flows or tasks that you are doing yourself, and then you want. I just wonder if sometimes it's fear that I'm going to be replaced by the robot. And then what is going to happen with me as a professional? So that's also a question that I put there outside.
Definitely a valid question. All right, I think we have time for one more question. Sorry. Anyone have a question? Angelica, I was wondering, what resources would you recommend if your product team does want to get into AI? What are there any classes or books that help you?
Oh, yes, definitely. Go to Coursera. IBM has a foundational class. There is Google has, let me paste the links here because I actually put those links here. Here, Google has these documentation that I found very, very useful in very simple terms.
Awesome.
So, yeah, this one, that's one. IBM and Coursera has foundational courses. NVIDIA launched foundational courses and more advanced courses. So I would recommend do the foundational courses. And yeah, that's it.
That's awesome. Thank you for dropping those in. I had no idea or IBM had a course or a resource on that. So thank you.
Yes, you can definitely access those through Coursera.
Perfect. All right, Coursera, IBM, lots of resources out there. Well, Angelica, once again, let's go ahead and applaud Angelica for being here. Great talk, very topical. We are so thankful to have you here sharing your experiences and your insights with us. So thank you. And also, this recording will go up on our YouTube channel. If you guys haven't subscribed to that yet, definitely subscribe. We also have been turning out different YouTube shorts on there using AI. So definitely check that out because yeah, Angelica, you went through so much. I'm definitely gonna have to watch the recording again.
Thank you so much, guys, for having me. Thank you so much for, yes, give me your time, and I hope to see you.
Awesome.
Facebook group and LinkedIn.
Yay.
Maybe I can come back and
Right.
another topic on this field.
Thank you. All right. At this point, everyone but the organizers and speaker, feel free to log off. I know it's late. Go have dinner. Enjoy yourselves. Have a wonderful night, and I'll see you either later this month on the virtual call or next month at the Legility office. Good night, everyone.